5.2 is something that we should already know how to do, basically. We're just gonna make sure that we kind of like cover it, and then we're just gonna be done in like the next 5 minutes. So 5.2 is all about tangent and normal lines. Again, something we've pretty much covered, but it's a nice little entryway into 5.4, which can be a bit more interesting, a bit more difficult, to be honest. Tangent line. What do you guys know about the tangent line? Do you know anything about the tangent line? Okay, so good. Maybe this is worth our time. A tangent line is a line where the gradient, Monday handwriting, is parallel to the instantaneous rate of change. So we have a graph. The tangent line will only have one intersection, and it will be parallel to the instantaneous rate of change, or it will have the same rate of change, however you want to think about it. It's going to nicely glance off our curve. It's kind of like it represents the instantaneous rate of change, but yeah, that doesn't really make all that, like, that doesn't really hold up if we kind of leave it like that. There's many different, there's a tangent line at every different point. If you do a whole bunch of tangent lines, you'll get this really kind of neat effect. And that just kind of shows you that the graph and the gradient of that graph are just nicely changing from this equation from negative to near zero and then back up to positive. There's not really much else for us to talk about when it comes to tangent line. I guess it's worth pointing out that parallel has this little shorthand where you can do kind of two lines that look parallel that are on a little bit of a slant. So if you see that, it means parallel. Yeah. I guess the last thing I'll write on here is that as far as tangent line goes, point slope form is definitely our favorite, which is y minus y1. Sometimes people put those in parentheses, but you don't really need parentheses on that side. In x minus x1. Point slope form is definitely our best friend when it comes to tangent lines, because you're gonna have the slope at that instantaneous point, and then y equals mx plus b, slope intercept form, is just kind of worse. And normally when you're kind of learning math, it's like point slope is the confusing one and slope intercept is the best. And just kind of a recommendation, use this point slope form and don't convert it to slope intercept unless you have to. It's just a waste of your time. You might make a mistake converting it when there's no reason to. So my advice, point slope form, and unless they say slope intercept, just leave it alone. Make sure you get your negatives right, but you guys are ready because you get that. All right, let's speed it up a little bit. I've definitely got the Monday morning slow talk. Let's go. Up next is the normal curve, or not the normal curve, the normal line, I guess. The normal curve is whole different thing, the normal line of the curve. And it's basically, I'll just do the one that's upside down. It's basically just the opposite of a tangent line, or the perpendicular of a tangent line. You pick a coordinate, you consider the instantaneous rate of change, and you choose the perpendicular to make your normal line. So if we think about this point, which looks like it has a instantaneous rate of change of about 1, then the normal line will be -1. It's gonna kind of stab through the graph. You just start taking perpendiculars, and it's one of those things where it's called normal, and you would think that it would be have some sort of simpler or like more straightforward application. But basically, normal line just kind of exists for them to, like a little gotcha, right? I was doing the homework when I was distracted. I was babysitting another class, and when I went over the homework with the HO kids, I had made a mistake because I just didn't see normal line, and so I wrote the tangent line in the question, so the key had a mistake. That's pretty much like all that the normal line is good for. Is for them to just put it in the question, find the normal line, and half the class just doesn't realize that. They do the tangent, they stop. So normal line is gradient perpendicular. That's not line. Perpendicular to, I guess write it out. So let's, like I said, let's do a question that looks more like an ID question, but it's kind of been a while since we did this. I'll get you this when we finish on. This is, this is a question. I don't know that we're going to do all of it, but we have an original function f of x, and if I was just going to sketch this for the sake of it, it does look like a quadratic. It does have an a value of 2. It does have a y-intercept of 10. So I don't really know much about how this looks just from a snapshot. It might look like this, but also it might look like this, or like this, or like this, or like this, but it's some sort of U-shaped graph. So find the equation of the tangent of the line and the normal line at boom, 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 3 different places. I'm not sure that we're going to do all 3 of these because I don't want to be sort of unclear, but I guess let's go a little bit faster. I feel like I'm just snail crawling this morning. A says find f prime, f of x is 2x squared minus 12x plus 10. F prime, power rule. Nice Monday mornings early. We don't mind that at all. There you go. Easy. B. Find the equations of the tangent line and the normal line. So we want both at all 3 points. How are we going to go about finding these normal lines and tangent lines? What do you think? How do you want to start? B for I. Any ideas? A tangent line, a normal line, it needs point and slope so that we can make point slope form. Of course, we like to say gradient a little bit more in IB, but whatever. We're looking for point and slope. How can we get a point and how can we get a slope? What do you got?
You just substitute the first one, x equals 1 for the derivative equation.
Okay, so let's put this into the derivative. I'm with it. So when we do that, f prime of 1 is equal to 4 times 1 minus 12. our instantaneous rate of change at 1, but we need point slope form. And if that's the slope, how do we get the point? Again, not meant to be a super hard question.
You just plug it into the original.
Nice. Nice job. We just take the 1 and we plug it into the original. F of 1 is equal to, and then luckily multiplying by 1 isn't that hard. 2 times 1 squared minus 12 times 1 plus 10. 1 squared is 1, 2 times 1, so that's going to be 2 minus 12 plus 10, 0. And what is that 0? That's the y value of the coordinate, 1, 0. And so now, let's get our tangent line, or like point slope. Y minus 0 equals m negative 8 x minus 1. Now you definitely, again, no reason to make this slope intersect. Point slope is fine. Maybe we don't need to put the minus 0, right? I mean, if you want to be rock star who's heading towards those 5s and 6s and 7s on those IB exams, not that the minus 0 is going to kind of be crushing you, but just get used to 2 seconds of making things look nice. It does go a long way. Okay, sweet. This is the tangent line. Let's get the normal line. And here's what's nice. It's basically the same exact thing, except for our gradient is the perpendicular. So y equals x minus 1. If my original is negative 8, the perpendicular is the opposite reciprocal, positive 1/8. And that's it for this bit. So, what are we learning today? Because this, honestly, is something we already pretty much know how to do. We've already talked about how the derivative tells you your instantaneous rate of change. So today, we're going to be focusing on questions where we used to just be finding the derivative, finding the derivative, finding the derivative. And obviously we know how to use the derivative. But today we're going to look at questions where we need to use the original for something, we need to use the derivative for something, and we just need to consider all of these different pieces. Calculus is not about like find the derivative and forget about the first function, the original function. So today we're going to be incorporating all this kind of stuff. Let's do one more and then we're done with tangents. You want to do I or I? Want to do 2 or 3? Just somebody shout something.
2.
Thank you. Say. Favorites. Favorites. 2. 2 is at x equals 2. It's the same exact coordinate. So, gosh. We're going to basically need to plug it into the original and we're going to plug it into the derivative. Because we need the y value and we need the instantaneous rate of change. I'll start with the original. 2 times 2 squared minus 12 times 2 plus 10, which is going to be 2 squared is 4 times 2 is 8. 12 times 2 is negative 24, and then plus 10, that's going to be 18 minus 24, that's going to be negative 6. That's my y value. Then I'm going to go with f prime, and f prime, we saw it up here is 4x minus 12, so 4 times 2 minus 12, which is going to be 8 minus 12, which is going to be negative 4. Which is going to be my m value, and then let's do point slope form for the tangent, which is going to be y not too bad. While we're here, I'd say trying to build our work so it just looks a little bit nicer. You know, things like this, things like this to help, you know, you keep track of what is what are pretty nice. Especially in my HL1 class with the juniors. If something is going to be worth more than 1 mark, then you need to have some work before the answer. In case the answer is wrong, you might get credit for the work. So a lot of them were doing tests where it was an easy 2-pointer, except for they went right to the answer and they got it wrong and they missed all 2. Some of the kids that got it wrong, who wrote more, got a point for free. So the way I like to do these longer questions is I just write basically as much as I can. Okay, this is tangent lines, normal lines. How we doing? Honestly, this should feel pretty in control.